Okay, so today we're going to continue on with the exponential war problems. And we're going to see more examples of when to use the four equations that we talked about yesterday. Okay, just to recap, do you guys remember the four equations that we yesterday? The four exponential equations? Y equals A, B, to the power of x, right? So, but this is basically the simplified format of it, but then we had four different ones. We had exponential growth with rate, exponential decay with rate, and then we had the doubling and the half-life. Do you guys remember these four? So the exponential growth with rate, it was y equals a 1 plus I to the power of x. You guys remember that? And then what would be the exponential decay? Mm-hmm. Minus I to the power of x, right? And then we had the doubling life, which is y equals a 2 to the power of t, or whatever the thing is, or x over d, where d is the doubling life. The half-life, which is y equals a half to the power of t over h. Okay? So we're going to use these whenever we're solving word problems. Now, the decision that you guys have to make is which one do I use? Okay? So let's read the first question. So a principal of 5 is invested at 8% per year, compounded annually. Write an exponential equation to represent the relationship. Okay? So a principal of $500, what does that represent, that $500? That's your initial value, right? So that's your A value, right? Is invested at 8% per year, compounded annually, and then we're gonna write an exponential equation. Is this a growth or decay? Growth, right? So since it's at rate, that means I have to use the 1 plus I formula, right? So you're gonna start with writing your generalized formula, which is y equals a 1 plus I to the power of x. Then we're going to sub in the initial value, right? So where A is, we are going to replace it with the initial value, which is in this case, it is 500. Okay? I'm showing you step by step here what you need to do, but at the end, you don't have to show me that specific step, right? You can plug in 500 and the I right away if you want. Now, what would be my common ratio? So, remember that if it's doubling, what do we use? 2. Half-life? Triple? 3. Now in the cases when I have a rate, right, for percent, I'm going to have to convert the percent to decimal. And then for the growth, it's going to be 1 plus I. And then for the decay, it's going to be 1 minus I, right? So we've already written the equation like this, so I don't have to worry about all of these rules, right? Because I've already picked the right formula. So what am I going to plug in for I? 0.08, because what I have to do is I have to change my percentage to decimal, and I do A divided by 100, and I plug it in for I. So that gives me an equation of y equals 500 bracket 1.08 to the power of x. Now this is an exponential equation, right? My exponent is a variable, it's a letter, right? And this is called an exponential equation. Now this question doesn't ask me to solve for anything else, it just says determine the equation of the exponential relation. And this is the equation. I'm done. Okay? What could be some questions that I might be able to ask you right now after this? So after, let's say, 3 years or 5 years or 10 years or whatever, what is the amount of money that you have in the bank? Right? And in that case, you're gonna plug in a value for x, so whatever the value I give you, right? If I give you 10 years, you're gonna plug in 10 for x and then do your math. Okay? Remember, you have to follow bed math, so you have to do your exponent and then multiply by the power. Okay? Are we okay with this? Okay, so the second question says a new car costs $20,000. Its value decreases by 16% per year after it is purchased. Write an exponential equation to represent the relationship. So let's see, what is given to me? What do I know? What equation do I use? It's a decay, right? So it's going to be the y equals 1 minus I to the power of x. Okay? And do I know what A is? So your initial value is 20,000. And then what's my I? Which is 0.16. This is a decay, right? You see the base, your base is 0.84. And because your base is less than between 0 and 1, you know it's a decay, right? So you know that you kind of done this. Are we okay with that? Okay. So the population of Alberta between 1987 and 2005 can be modeled by an exponential equation. The population is in 1987 was 2.4 million and the growth rate was 1.7%. Write an equation to model the situation. Growth or decay? So what formula do I use? Okay, what's my initial value? 2.4 million. So 2.4 million, I'm gonna write that as 2.4. I'm gonna say that population is in million, right? So when I get my answer, I have to always multiply it by. Okay, and then 1 plus what? 0.017. You're going to have to take your percentage and then you're going to have to divide it by 100. So my equation is going to be y equals 2.4, 1.017 to the power of x. Are we okay with that? The question is asking for the equation. I did find the equation, correct? Now, the second question is asking you to use your model to calculate the population in 1985. change my base. I can't change my equation. This is the equation that I got and I have to stick with it. But I do understand what you're saying. 1985 is before 1987, right? So 1987 is your year what?
Year 1.
Is your year 0. So if I'm looking at 1985, that's 2 years before the year 0. So what would that be? -2. So what I do is I plug in -2 for my x. I don't change my rate, okay? Because I've already found the equation. The equation doesn't change. What you have to think about, since 1987 is my year 0, 1985 is 2 years prior to that. So I'm going to have to plug in -2 for x. Make sense? And your answer for this is going to be, should be 2.32 million. Does that make kind of sense? Did you guys get that? No. What do you guys get? 1.7? Which doesn't make sense. $2.32, yeah? So if you don't know how to enter it in the calculator, it's time to ask. So 2.4 times 1.017 power negative. You have to do this first. I need you to get a calculator. Power, so 1.017 power 2 and negative, of course, equals, and then multiplied by, did you multiply by 2.4? No. Looks like, yeah. Yeah, you already multiplied it. But I would get a power calculator, okay? All right. Now it's asking to use your model to calculate the population in 2012. So, how would I know? This is it from 2012 to 2012.
2012
So 2012 minus 1987, right? Because that's my year 0, right? So the answer is going to be 25 years. So I'm going to replace this with x, right? So it's going to be y equals 2.4, 1.017 to the power of 25. And your answer should be about 3.66 million. Technically, you should write more decimals just to be more accurate. So it's going to be like 3.657927. But I'm going to stop right there. I'm gonna give you an equation right now. So the population P of penguins in one region can be modeled by the relation P equals P0 to T over 60, where T is the time in month and P0 is the initial population. To you is, what does the value 60 represent in this equation? Double. The doubling what? Population. What does it mean? What does that 60 represent? So every 60 months, the penguin population doubles. Okay? So that 60 represents the doubling time of the population. Okay? So that 60 is the doubling time of the population, which means the penguin population doubles every what? Why did I say month? How did I know that it's month? Because T is in month, right? And they have to be the same. Good. If there are 400 penguins in this region today, approximately how many penguins will there be in 2 years? So today we have 400 penguins. How many? I'm just basically summarizing the question. In 2 years. I know if you read it, it doesn't make sense, but I just read it to you guys. So what do I do? What do I know?
Double would be 60 months. So, 2 years.
So today I have 400 penguins. I want to know how much do we have in 2 years. And I know that my equation is P equals P0 2 to the power of T over 60. So what's given to me? What do I know? The initial, which is 400. So I'm going to use it. I know that the initial, which is P0, equals to 400, right? Do we understand that? Because it says here that P0 is the initial population. Okay? All right. What else do I know? Which is already in my equation. I don't have to write that. But they gave me the time, right? What's my time? I'm looking for 2 years. Can I just put 2 in for T? No. I have to convert it to months because T, right, should be in months. So T equals to 2 years times 12 months, right? I'm just going to write this so you guys know where I got the 24 from. Is equal to 24 months. looking for?
How many?
How many? So I'm looking for the final population, right? I'm looking for, if I look at this, I'm looking for my final population, which is P. What's the equation that I'm going to use?
Equals 400.
P equals, I'm gonna write the equation first as is, and then I'm gonna plug it, okay? So that's the solution. So P equals 400, bracket, 2.
2. T 5.
So what's T?
24.
T is 24. So it's gonna be 24 divided by 6. Make sure that when you enter this in the calculator, you're gonna enter it like this. 400 times 2 to the power of, when you put your exponent, it has to be in bracket. So you have to do this. I know each calculator is different, so you might have to use different buttons, but it's the same process. Are you guys getting this?
No. Am I gonna be able to?
Yeah, with brackets. You see the brackets? Yeah. Should be getting 527.8 or something like this, where we can't write that, so we write it as 528 because I can't have partial of a penguin. Okay, same with population, you can't have point something of a person. So my therefore statement is going to be in 2 years, the population of penguin is this question as 528 and put that answer on the board and left you guys hanging? I could have, right? I could have just did it in my head and then put just 528, right? But would you have understand what I did? No. Same thing on the test. If you just give me the answer, I'd be like, okay. How do you get that answer? I don't know. That's your 0. Okay, I'll give you marks as much as you give me, right? You see that I've showed you a process, right? Did we talk about grasp before? Did we talk about this method before with you guys? So basically what the grasp method is, it's following kind of like a method so you show your work, okay? So under the G, we write what is given to us. Okay, so what did they give me? What did the question give me? The question gave me that my initial population is 400. So that means P0 is 400. I don't write words, I write symbols. You see? Because initial population represents P0, I wrote P0. I know that T is 2 years, and 2 years is 24 months. So I wrote T equals 24. You see how I'm showing you what is given? So this is what the question had given. Under the R, I write, what is the question asking me to solve for? Okay, so the question is asking me to solve for the final population. So it's asking me to solve for P. And this is what I wrote, P equals to question mark, because this is what I'm looking for. Then under analysis, which is the A, I write the formula that they give me. I don't plug in anything in it. I just write the formula as is. You see how the formula that was given to me, I write it as is. Now, in the solution, this is where I plug in my information. Right? So in the solution, this is where I plug in 400 for P0 because this is the given information that they've given me. Right? They told me 400 is P0, so I replaced P0 by 400. And they told me that T is 24, so I replaced T by 24. So all what I did is what we call substitution. Okay? Then I enter it in my calculator to find my answer. And at the end, I write my very first statement, which represents the per phrase or the letter P. So it's a process. Grasp, G is for given, R is for required, A is for the formula, which is analysis, S is for solving, and P is for the per phrase. If you want, you can take a picture of this grasp solving equation method, right? You can take a picture of this so you can have it as a reference out. Okay? But this is what I'm expecting from you when you're solving a word problem. Right? You might at the end not end up writing GRASP, right? But at the beginning, just to get yourself used to it, you probably want to. So the second question is, if there are 1,000 penguins, so I'm going to leave you guys with this question. If there are 1,000 penguins in this region today, how many penguins will there be in 3.5 years? Okay, so I'm going to leave you with this question. Show me your grasp method and make sure that you follow these steps.